Hi and welcome to the video training of Elixir. In today's video training we will be discussing Erlang Libraries. Elixir provides excellent interoperability with Erlang Libraries. In fact, Elixir discourages simply wrapping Erlang Libraries in favor of directly interfacing with Erlang code. In this section we will present some of the most common and useful Erlang functionality that is not found in Elixir. The binary module. The built-in Elixir string module handles binaries that are UTF-8 encoded. The binary module is useful when you are dealing with binary data that is not necessarily UTF-8 encoded. So let's get started. Enter the interactive mode of Elixir and start with string2 underscore list, and I'm going to copy this character from here and we got 216. Now let's try binary .bin to list and pass in the same character, and we got 195 152. The above example shows the difference. The string module returns Unicode code points while binary deals with raw data bytes. Formatted text output. Elixir does not contain a function similar to printf found in C and other languages. Luckily, the Erlang standard library functions io.format and io.lib format may be used. The first formats to terminal output while the second formats to an IO list. The format specifiers differ from printf. Refer to the Erlang documentation for details. So let's look at io.format. io.format, and let's pass a string. Pi is approximately given by colon by 10.3 f n math dot pi closing braces, and we get pi is approximately given by 3.142. and similarly we can use toString underscore string space colon io underscore lib dot format, and same string and function that we used above, and this gives us a string that says pi is approximately given by this. Also note that Erlang's formatting functions require special attention to Unicode handling. Let's look at the crypto module. The crypto module contains hashing functions, digital signatures, encryption, and more. So let's start with base.encode 16 and call the crypto.hash function and pass in SHA-256, and the string we are going to create hash is Elixir, and there you go. The crypto module is not part of the Erlang standard library but is included with the Erlang distribution. This means you must list crypto in your project's applications list whenever you use it. To do this, edit your mix.exe file to include it. So in your application you need to define extra applications and crypto. The Digraph module. The Digraph module as well as Digraph utils contains functions for dealing with directed graphs built of vertices and edges. After constructing the graphs, the algorithms in there will help find, for instance, the shortest path between two vertices or loops in the graph. Given 3 vertices, find the shortest path from the first to the last. So let's explore this module. Digraph equals colon digraph dot new. Okay, chords, are the coordinates, and going to pass in 0.0 comma 0.0. okay, 1.0 0.0 1.0 1.0. okay, these are our coordinates, and now we are going to mention the vertices v0, v1, v2, and loop for C. Coordinates do colon digraph dot add vertex digraph comma C. Okay, now I want to add edge digraph dot add edge digraph v0 v1. so there you go. Similarly, we want to get the shortest path, so digraph dot get short path digraph comma v0 to v2 undefined function digraph vir. Okay, we get false. Short path 0v2. Note that the functions in digraph alter the graph structure in place. This is possible because they are implemented as ETS tables explained next. Erlang term storage. The modules ETS and DETS handle storage of large data structures in memory or on disk respectively. ETS lets you create a table containing tuples. By default, ETS tables are protected, which means only the owner process may write to the table, but any other process can read. ETS has some functionality to allow a table to be used as a simple database, a key value store, or as a cache mechanism. The functions in the ETS module will modify the state of the table as a side effect. So let's define a variable table ets.new ets underscore test. Okay, now let's insert some data. ets.insert table China, and let's enter some value, colon 374 core 0000000. Okay, that's inserted. Now let's insert it for India, and it's 1284. Similarly for USA, and it is 322. Okay, now if I call ets dot I table, I get the data saying India, USA, and China. The math module. The math module contains common mathematical operations covering trigonometry, exponential, and logarithmic functions. So let's look at these at a glance. Math.py multiply by 45.0 divided by 180.0. Okay, we get that. And if I want to find a sine of angle 45 degree, okay, let's start again. 45 degree equals math dot pi multiply by 45.0 180.0 and math dot sine angle 45 degree. Okay, this gives us the sine of the angle. And for exponential value, math.exp 55.0, this gets us the exponential value. Then we have math.log, and here we can pass in the value we want to get log of, and there you go. The queue module. The queue is a data structure that implements double-ended FIFO first in first out queues efficiently. To define a new queue, you just need to call queue.new. Now let's add some data. queue.in a colon queue. Now add b to the queue. Okay, now let's try value colon queue comma queue equals colon queue dot out queue. So we get a. Now if I check the value, I get a. Now let's try value queue equals colon queue dot out queue. This time I get b. So it's a first in first out queue. So first we get a, then we got b, and now if I try queue again, I got empty because the a and b are out of the queue now. If I check the value, I get empty. Let's look at the rand module. Rand has functions for returning random values and setting the random seed. So if I type in rand dot uniform, get a random value. Similarly, if I try rand dot seed exs 1024 comma 123 35 34 345 345, and here we get the seeding value of random numbers. Rand dot uniform, the random value again. Pass rand dot uniform 6, I get 6. Let's look at the zip and zlib modules. The zip module lets you read and write zip files to and from disk or memory, as well as extracting file information. This code counts the number of files in a zip file. So if you have a file called file.zip in the same folder as Elixir, you can run this command to count the number of files in that zip files. In this case, it's saying 633 files exist in the file.zip file. The zlib module deals with data compression and zip lib format as found in the gzip command. So let's look at an example. We're going to compress a string. Okay, now we have a song variable with this poem. Mary had a little lamb, his fleece as white as snow, and so on. Now if we want to compress this string, you can call zlib.compress function and pass in the song variable. Now it's compressed. If I want to check the byte size of song, I'll get 110. Okay, if I want to check the byte size of compressed, I get 99. And if I want to uncompress, the compressed poem, I'll get the same string that we inserted in the first place. If you like this video, don't forget to subscribe to my channel. If you need any help, feel free to contact me at umahmood@gmail.com or visit my LinkedIn profile or my Twitter handle. See you next time with a new topic in Elixir.